So, slide 11, we're going to be looking at our relative maximum and relative minimum. And so our relative maximum is found at the point where our function is the highest, and so where we have a high point. And then our minimum is found where our function is the lowest, where we have a low point. And we call these relative because these high points where we kind of see these bumps in the graph, these are not the absolute, what we call absolute maximum, because it's not the absolute highest point in the graph, but it is a high point for its area. It's a little bump. It might end up being the highest point in the graph, but for some like this one here, it's a high point, not the high point. Okay? So let's go ahead and look at our example that we have there. So I'm going to go ahead and pause, people, come back to our Google Meet so you can watch how I'm going to be working through this, and then you can go ahead and get it on your set of notes. So our relative maximum, let's see, our relative maximum we have right here. Hopefully we see that we have a nice high point. That's where we're going to have our max. And then down here is where we're going to have our minimum. Okay, so we have a high point, that's where we find our max. We have a low point, that's where we find our minimum. And to find the exact value, because our question is find the points where the relative maximum and relative minimum occurs, and what are the values of the function at these points. So if I go to my relative maximum here, I go ahead and I say there's my maximum point, and I come over to my y-axis. This gives me the value, that maximum value, that high value. We always, when we deal with maximum minimum, we kind of relate back to the y-axis and see what is the value of that point at that maximum value. So this is going to be, see, it looks like I'm going by 5, so 5, 10, 15, 20, 25. So I'd say that looks like about maybe 28, 29. Looks to be pretty close to 30, so I'm going to say maybe that's 29. So I would say my maximum value is 29. So in my box here, I'd say max is 29. And now I want to know where my minimum value is. And let's actually just go ahead and put the point. Let's see, what would be the actual point for that? Let's see if we come down to our x-axis. Where does that occur? Again, this part, it's going by once, 1, 2, 3. So I'd say maybe about 3.4, negative 3.4. So my max is 29. That's coming from the point negative 3.4, comma 29. Okay. All right, let's go ahead and see what is my minimum value. So down to my minimum value down here, I come over to my x or my y-axis to find my value. Again, that's going by 5, so that'd be 40. That's 45, so that'd be, I'd say probably around 42, so maybe negative 42 as my minimum value, negative 42 about. And let's go ahead and say what is the point there. So let's see if we come back up to, looks like I'm nice on a line. So that looks like an x value of 2. So it looks like my point is 2, comma, negative 42. All right. So our maximum value is 29. My minimum value is negative 42. All right. So that is how we do maximum minimums. I'm going to go ahead and open up both 12 and 13 as well. Go ahead and get that information on. I'm going to unpause. It's unpaused now, so you can go back to Desmos, get the information I have on my screen. I'm going to leave it there for a second. You can go ahead and get that information in on your screen. When we give the maximum minimum values, it is a y value we give, but go ahead and tell us what the point is as well. So maybe I'll actually add that in. The point is there. All right. So go ahead and take the next couple minutes to determine your maximum values. Get that information in on slide number 11, and then you can move on to 12 and 13 and get the maximum minimum values for those two as well. All right, so I'm going to put a timer for about 3 minutes to get that, and then we'll move on to the next thing that we have. All right. So let's just quickly touch bases on number 12. So we have number 11 here. Let's just quickly look at number 12 together. So if you want to head back over to the Google Meet. So looking at this one, it looks like I have a nice maximum at this point up here. If I come over to my y-axis, that looks like we're going by 2s. That I would say is close to maybe 13 or 12.5, 12.5 or 13. I'll just say 13. So for number 12, I'd say my maximum value is 13 maybe. And then going down here, if I go to my minimum over to my y-axis, that one looks to definitely be about maybe negative 20.5 maybe. Or maybe 21 if you just want to round it up to 21. But I would say that would be definitely our maximum. Is max about 13, minimum about 20.5 or 21. Okay, and that's what we'd want to type in there. All right. So let's go ahead and go to the next thing we have, which is looking at when our functions are increasing and decreasing. So I am going to push everybody over to number 14. So we only have about 11 minutes or so, so we're going to push everybody over to number 14. So make sure you are in the Desmos so we can move over to number 14. All right. So on slide number 14, we have some information about increasing and decreasing functions. So when we identify the parts of a function that are increasing and decreasing, we describe the parts as intervals of the x-axis. So for example, on the third function from the left, we could say that it is decreasing for the x values between -4 and 2. So let me just go over that just a little bit more clearly here. So if you're looking in the Google Meet, that would be helpful. So we see on the third function, so when I'm saying third function, I'm looking at this one. I know it's a little bit hard to see on your screen, but we have this section right here that is decreasing. We are going down. So that's our decreasing section. And let me actually zoom in just a little bit. And it's not exact, but it looks like if I come down from that maximum point, I am at -2 on my x-axis. I come up from, or -4 rather, sorry, -4 on my x-axis, and if I come up here, I'm at +2. So I'm saying that the function is decreasing for all x values between -4 and 2. So that's how we describe, it's similar to how we do the domain and range, is we describe how we're increasing or decreasing by looking at the x-axis. We'll go over what we'll do on the next one, but that's what we're saying there. So for that example, we are decreasing between -4 and 2 for all x values between -4 and 2. That's where we are decreasing. Okay, so let's go ahead and do, let's see, let's go on to number 15 and see how that one would be done. So I'm going to go ahead and pause everybody. I'd like you to just come over to the Google Meet, and so you can kind of see how this would be done. If you want to get anything on a piece of paper, then be able to copy it over, that's fine. Or if you would just like to kind of observe as I go over this, that is fine as well. All right, so we want to find when the function is increasing and where the function is decreasing. We're going to use different colors to indicate those different parts of the graph. So this, first off, we want to know that this function is going on forever. It's extending beyond this graph. Okay, that is not where it ends. It continues on. So I go to my maximum point, and I see that this portion of the graph is increasing. So I'm going to go ahead and label that. It is increasing. We also have another part of the graph that is also increasing, and that is over on this side. So we are also increasing, let's see, here we go, from this minimum point going on, that is also increasing. And so this middle section of the graph is where we are decreasing. So from this maximum point down to the minimum point, that is where we would be decreasing. Okay, so hopefully that makes sense. So that is where we're increasing, and then that other point where we are decreasing because we're going down on that section. Okay, so we travel our function from left to right. So if we're going left to right, we're going up, hit that high point, then we go down, hit that low point, and then continue up, kind of like a roller coaster. All right. But to identify that, I need to go ahead and go to the x-axis. So from that high point, I'm going to go down to my x-axis, and that is at, looks like 1, 2, 3, so at -3. My graph is increasing for all x values less than 3. Okay, so I'm going to go ahead and type that. So where we are increasing is going to be all x values less than -3. Okay, then let's go ahead and go to our next section, which is decreasing. And it looks like we are decreasing for all values between, so again, I go down to that x-axis, so we're between -3, and then here I come up to my x-axis, and I'm at +1. So we're decreasing for all x values between -3 and 1. So I go ahead and write that. So we are decreasing for all x values between, if I can actually spell, between -3 and 1. And then our last section of the graph is another increasing, so we are increasing again. And that looks like, let me change my color back to the blue. So I am increasing, so that lowest point, so that's starting at 1. Continuing on forever in that direction. So that would be all x values greater than 1. Okay? And that is what we do to identify those sections that are increasing, decreasing, increasing. Sometimes we'll also get into sections that are constant. For right now, just increasing, decreasing. Okay? So hopefully that makes sense. I'm going to go ahead and unpause everything, and I'm going to open up 16 as well. So go ahead and get this information in from what I have here, get it inputted on your slide for number 15, and then you can go ahead and do number 16 as well. I'll just want to comment on looking at some of your work for number 15. I saw some people just indicating the increase instead of writing it out increasing. Thought it was really smart. They used little arrows showing that we're going up, and then on the decreasing using an arrow showing that we're going down, and then the other increasing again, an arrow indicating that they're going up. I thought that was a smart way to mark it up instead of actually writing out the words increasing, decreasing, just showing it with those arrows. All right, ladies and gentlemen, just checking on the time. We are at the end of the class. I'm going to be leaving this up on my screen for a second, for a little bit if you're still getting that down, or maybe take a screenshot or a quick picture of what I have on my screen so you can get that down if you haven't already. I've opened up the entire Desmos activity, so if you go ahead and go through and make sure everything's done, that is your homework assignment, to go through and make sure everything's done. then also to do the last 3 slides, 17, 18, and 19. It's really just 18 and 19. On these ones, we're kind of putting everything together that we have learned. You're given 2 graphs on each. You're going to identify your x and y intercepts. You have to identify your domain and range, your max and mins, and where you're increasing and decreasing. So everything that we've looked at from yesterday and today, that is what you're going to put in on those. Okay, and you can just, if you look at 17 and 18, you'll see they're numbered. Those different things are numbered. And so you can say part 1 or number 1, this is what I have for my x-intercepts. Number 2, this is what I have for my y-intercepts, and so forth. Okay. But again, we are over time, so we're going to go ahead and end there. If you have any questions, please let me know. We will look at some of this stuff a little bit more tomorrow, kind of check bases. But if you have any questions later today, please let me know. All right. And have a wonderful day, everybody, and we'll see each other tomorrow.